How's everyone doing this morning? Awesome. Super excited to be here. Thank you for having me. This is an amazing conference. I really do enjoy Bondarev. It's my second time here. So today I'm going to talk about building AI agents in Ruby. So how many of you work with LLMs? And how many of you have built an application that uses an LLM before? Okay, a few, maybe 10. How many of you can explain what RAG is? Okay, less, so like 3 people. All right, in my day-to-day, I run a small software development consulting agency where we help VC-backed startups and mid-sized enterprises build custom software. The rest of my time I spent developing open source solutions and kind of doing applied AI work and trying to figure out what are the best ways to implement some of these newer capabilities that we've been seeing in the last couple of years into our stacks. I've been able to collect some of these stickers throughout and been fortunate enough to help some of these companies. Who remembers Spree? Does anyone still run a Spree store or Solidos? What an iconic library. And so I think this summarizes the Gen AI impact pretty well. What used to take half a year to build out now can just be done within a couple of days or a couple of weeks. And so some of these most common machine learning tasks, such as taking unstructured data and converting it to a structured format, or summarizing large text, or classifying documents, translation, content generation, named entity recognition, are just an API call away. So as these capabilities have significantly dropped in price, there's a long tail of medium to small size companies that are implementing these capabilities. So now some of these AI features are no longer reserved to the FANG companies. And so I'd like to propose a view that we're going to have this intelligent compute engine inside of every single stack. Just like every single tech stack now has databases and cache and encryption and queues and Lambda function storage, and it supports different protocols. You're going to have an LLM embedded into your tech stack, accomplishing different tasks. And really, I think we're going to have AI agents actually embedded into every single enterprise and chipping away at different tasks and workflows of every single department. So, of course, this is not the first time that we're talking about AI agents. So in the 1950s, when Alan Turing had published his famous paper, he introduced the concept of intelligent machines. It is the same paper that he introduced the Turing test. And then in the 70s and 80s, the community researched and worked on expert systems and software agents. And you might remember the original chatbots with Alexa and Siri. And we're taking another stab at it now. So every major tech company is presenting their vision around this. So for example, Google has its own custom AI agent builder. That's ironically called a gem manager. You can build gems. Ruby's making a comeback. So what is an AI agent? Well, the textbook definition is that it is an autonomous system that's capable of perceiving its environment, making decisions, and taking actions to achieve specific goals. So environment awareness, decision-making, and action-taking. So these two terms are used interchangeably, and I certainly use them interchangeably as well. I draw this kind of minor distinction that the assistant is more of a conversational. So it's a multi-turn conversation with a human or another system. And an agent is more of an autonomous system, kind of like a background job. You give it some tasks and it goes off running. So what are some of the use cases? Well, of course, the number one use case is broadly automating business processes. And I think we can tackle low IQ tasks. We can augment workers with personal assistants. We can also handle time-consuming tasks. So things that humans just can't do, like summarizing, like writing up an executive summary for a 200-page document within a matter of a couple seconds, or moderating 1 million images within a couple hours. And so, for example, in my small consulting business, we could be creating invoices from timesheets, categorizing business expenses, writing proposals, so remixing our service offerings with the notes that I've been taking in the client conversations and writing up proposals, writing job descriptions, JIRA tickets. And so when you think about building an AI agent, these are kind of some of the components to think about. So there's a reasoning and planning module, which is provided by the LLM. We need to inject our tasks, goals, objectives, workflows to the AI agent so it has a purpose. And we need a way to run the agent. So that's the concept of triggers. And we'll look at some of these in a sec. So when it comes to reasoning and planning, when we give our agent tasks and goals, it needs to be able to make a decision based on that information. It needs to be able to formulate a plan. And then, for example, the plan reflection is the concept where it's able to recursively revisit its plan and make sure that it's still valid. So whenever people talk about reasoning and planning, they bring up a chain of thought, and really all that chain of thought is just it's forcing the AI to explain its reasoning. So similar to how humans, when we're thinking out loud through the problem, we're much more likely to arrive to a better answer. So, for example, in this example, if we ask this kind of random brain cruncher and just force it to give an answer, then it's much less likely to give us a good answer than spending some time thinking how to approach this question. So it's much more likely to get to a better answer this way. And when I talk about business logic, so I'm talking about any kind of business-related tasks, goals, objectives, workflows, standard operating procedures. So I'm leading up to a demo that I'm going to do in a bit, but you can imagine if we run an e-commerce store, for example, we have procedures for processing new orders or processing returns that will enumerate all the different steps with some logic within those steps. So when it comes to triggers, we need to be able to run the agent. So kind of very similar to like Sidekick, right? It either monitors state changes, it runs on a schedule like a cron tab, or it's event-driven web hook, or you like that? Or you can manually run it. AI agents, well, really, large language models are stateless. So we need some sort of mechanism to save progress, save the context, save the tool calling output to memory, and retrieve it later. And whenever people talk about memory, they talk about RAG. I'm not gonna spend too much time explaining what RAG is, but I think we've largely overcomplicated what it is all throughout kind of 2023 and partially this year as well. All that it is that you take relevant context and you put it in the prompt. That's it. You don't necessarily need to use a vector database and generate embeddings and all that. That's the implementation detail. It's just that you're injecting relevant context into the prompt so that model can use that information. So it could be your proprietary data, etc. So tool calling and function calling are also synonymous, and you use them to produce structured outputs. So having the model generate a response in a predefined JSON schema, or when you needed to the intent detection utilize external tools. So think APIs, and so you would use tool calling to get data from external sources, because for example, those external sources are proprietary, and these foundational models were not trained on your specific data. The models are trained in a snapshot in time, so it has no concept of time, and it certainly doesn't. It's unable to access real-time data when you need it to take actions or execute deterministic tasks. So there's a really good article kind of called "Math is Hard" by Gary Marcus, basically showing that these LLMs don't really know how to do math, and it doesn't really make sense to use them for those tasks. And so, for example, if I ask it to sum up two really large numbers, it looks like the correct result here at the bottom, but it's not. But this problem has been solved. I mean, we can use a tool such as the code interpreter in this case, and it just produces a program that runs in a sandbox, and so that's the tool, and provides the response back. And so really the implementation looks like the following. So again, I'm leading us to the e-commerce related demo I'm going to do. So imagine so the function definition is in the open API-ish spec, and we can declare it different functions. So in this case, we have an inventory management class that has a function called find product, and it accepts a SKU. And whenever within the conversation there's a message that is relevant, the model, the intent detection chooses to invoke this function. So we extract the function name, extract the arguments, send it to that object with that method name and arguments. And so it looks kind of like this. So we need a way to inject the instructions, the business logic to the AI agent, and we utilize LLMs to reason and plan, store and retrieve from memory, take actions via tools. If it's conversational, converse with the user, and then we need some sort of a way to trigger the agent. And so I wanted to kind of briefly introduce a library that I've been working on called LangChainRB, and it's a way for building LLM-powered applications in Ruby. It's a living organism. It's evolving as kind of my conceptualization changes and the abstractions and what I really think would bring the value as well. We have, so there's a couple of things that it provides. It provides a unified interface into different kind of LLMs, so you can test out a number of them really quickly, swap them in and out. You can build AI agents, and there's also a pipeline to do a RAG as well. Demo. So imagine we have this fictional e-commerce store called Nerds and Threads that sells comfortable, nerdy t-shirts for software engineers that work from home. So who would shop there? And an e-commerce store has the following services, kind of self-explanatory what they do, right? And you can imagine these are different service objects with functions. And we're going to put an AI agent there to run the store, to facilitate the execution, to run our standard operating procedures. This is how I think about this. So the Ruby on Rails promise has always been developers focus on writing business logic and not the plumbing, right? So I think as Rails developers, we string services together, right? And we focus on these business use cases first and foremost. And previously, you'd have business logic in models or service objects or controllers if you're bad. And now I think some of this logic is going to start shifting to prompts and really AI agents. So we're going to set up this assistant class that we're going to inject the instructions on the left-hand side. We're going to use an LLM for reasoning and planning, and we're going to utilize these services. So this is what one of the classes looks like. I'm not sure I can make it bigger, but it is a customer management class, and we have two functions: create customer that takes in the name and email, and find customer that takes an email, pulls it from a SQLite database. And we're extending it with a LangChain tool definition module that provides that defined function DSL that basically converts this definition into an open API spec I mentioned earlier. Okay, so I think this is where we go to the demo. Okay, so we have this Nerds and Threads AI agent, and we're gonna pass these instructions. And so you're an AI that runs an e-commerce store called Nerds and Threads. It sells comfy, nerdy t-shirts for software engineers that work from home. You have access to the shipping service, inventory service, order management, etc. You're only responsible for processing new orders, refuse all of our workflows, and we write out the steps for processing new orders. So imagine we have a point of sale system that sends the following events. There's a new order event with the customer email, quantity, the SKU of the item, and the address. The first thing we do is we try to find the customer. So we call the customer management tool. Customer is not found. We try to create the customer success, customer ID. We have a customer ID. We find the product. We retrieve the product. We get back the SKU, the price, and there's 10 items in stock. We charge the customer, which is 5 items at the price of $24.99. We create the order record. And because the address is in the US, we use FedEx, and and this is a copy of the email that gets sent out. And so and I was actually slowing down the execution. So in between kind of every turn there was a sleep statement. So now let's say, so now let's say a return order event comes in with that customer email and the order ID. I changed my mind, I want to return it. And the system takes in the return order event and refuses to process the return. So we're going to try to see if we can implement that logic really quickly. So we append our return order steps, which say return order step-by-step procedures, follow them in this exact sequential order, look up the order, calculate the total amount, refund the payment, mark the order as refunded. And actually here we're also going to say that you're only responsible for processing new orders and returning orders. So if we take this return order event as well, let's see if it is able to run. So it finds the order. Refund the customer. Yep, successfully returned. So this was recorded in case I botched the live one. And another thing we can do, which I think is a really good use case, is like text to SQL. So, for example, we can we're utilizing the internal tool in LangChain, which is a database tool, which can execute queries and output the schema for your database connection string. So, for example, we say describe the database. And it should utilize the internal dump schema tool. And now we can say, what is it? Oh, drop. Yeah. Well, of course. If you're going to be doing this, you should create a dedicated database role that has permissions and access, and you should sanitize the output so you don't accidentally drop, alter, etc. Right. And now we can say what it is. Let's say how many. What? Let's see how much. What was I going to say? Oh. I don't know, on orders. Okay, finds the customer. Total spent. Okay. Oh, because I returned it. Yes, you're right. Okay. You're paying attention. That was a test. So, why would you use this? So, of course, it's far-fetched, and it seems like e-commerce has been solved for a very long time. We haven't seen all that much innovation, and you can change the requirements on the fly. So, if a CEO comes in and says, well, this is our 10-year anniversary of our store, and to all of our loyal customers, we want to offer a 10% discount on the orders today. how do you define a loyal customer? Well, they need to have spent, $100 or more in the last 6 months. Great, let's type it out, let's test it, let's ship it, right? Because the product team is going to tell you, well, not in this sprint, and we have to do scaled agile, and we haven't planned it out yet, etc. You can inject intelligence into your process, and you can tackle complex workflows as well. So of course you need to be able to evaluate this, and you need to just bombard it with inputs and outputs and see how your AI agent performs. You can ask itself to evaluate how it did according to certain criteria. So kind of recursively test itself. There's plenty of benchmarks on the Hugging Face, but of course for your specific use cases, you should be creating these data sets on your own. And if the agent reliability is not to your satisfaction, then you should be reducing the number of responsibilities or tasks, or kind of the shrinking the decision tree that it operates on. And of course you might say, well, Andrei, these things hallucinate and just really unstable. And this is kind of the way I've started thinking about this. So modern software still fails, and it fails because of the dependencies that we can't control. So maybe we can draw a parallel and say that, well, AI systems can fail because of inaccurate or incomplete data or bias in the data. This is a Ruby conference, so modern software can't scale because modern software fails because it can't scale. Well, AI systems also currently struggle from the massive compute needs. There's cloud outages that affects both sides. There's cyber attacks on one side and adversarial attacks on the other side. We don't test our software enough. And you could kind of draw a parallel to this black box behavior. And of course, there's still unclear liability and accountability in terms of the decisions that these AI agents makes, who's responsible for it. But I think these are engineering problems that will be addressed. So why am I doing all of this in Ruby? Well, I love the language. I think it's very elegant to express your ideas, and it lets me explore different concepts very quickly without thinking of semicolons and all this implementation. And I actually think in terms of DS, ML, AI capabilities, we're not that far from Python, where we have all these amazing libraries, but they exist in a snapshot in time, and of course companies need to invest in maintaining them. But I think the main problem is the problem of perception. So you're not going to lose your job on a AI project because you picked Python, even if the project fails. But you might just lose your job if you picked Ruby, because it's a very contrarian decision. So we looked at the current Gen AI wave, some of the tasks that it offers. We looked at how we can package up and think about building AI agents. I demoed this e-commerce example where it connects to different services that you can find in any e-commerce store out there, and how we can get the AI agent to run it. And I expressed my love to Ruby at the end, and yeah, that's it. Thank you. Yeah, it's a very good question. I think training is going to be. Oh, so your question was as you're iterating on a task, when do you stop prompt engineering, and when do you start thinking about training custom models? So I think the beauty of all this is that you don't have to train custom models. In terms of, I think training custom models is going to be reserved to still the largest companies out there, kind of the largest ROI on the line. The intention is that these foundational models are going to do, are going to be able to tackle 90% of the use cases, but and certainly the approach should be take the most capable commercial model out there, prove out that your concept works, and then scale down to maybe smaller models or open source models, once off of Hugging Face. Did I answer your question?
Yeah.
Well, I'm gonna compare it to Python, right? So very similar to Python, written on top of C, same kind of concurrency story, and a lot of times these Python libraries break into the C bindings, right? And I'm sure everyone is familiar with Andrew Kane's work, and he built a lot of kind of equivalents in the Ruby world. And I just find that we need to invest in maintaining those libraries. So I mean, if you're so the beauty of this is that there's this kind of concept, there's this title emerging of an AI engineer, right? And it's basically full stack engineers that are much more familiar with some of these data science, ML, AI concepts, right? But we're not necessarily going to be training models, but we're going to be doing applied AI. Yeah. Anyone else? Yeah, that's a very good question. Sorry, so I'm going to try to repeat it. So in the demo that I did, I wrote out specific constraints for the execution flow. Like one of them was if the address is in the US, use FedEx. If it's outside, use DHL. So how do we make sure that these constraints are respected, and how do we have the guardrails to make sure that it's safe to release into the wild, right? Yeah. So to be frank, I'm still trying to figure out like the best way to package up these workflows into these systems. So there's a lot of people that are looking at graph databases and kind of representing workflows as a tree, and really just utilizing the LLM like for making decisions, right? So if the node is generate a shipping label, right? There's a decision to be made that's a natural language decision, whether the address is in the US or in Europe. So use FedEx or use DHL. The beauty of using an LLM at this step is that it's able to process like an infinite number of different permutations, right? So instead of like writing a really long if else or regex, right? That instead of enumerating every single possible case that you could think of, in instances where the number of permutations is nearly infinite, right? The LLM can take its best guess, right? But certainly, I would put some structure around like inputs and outputs, right? And these foundational model companies are introducing all these concepts to try to put some more rigidity around this inference, like tokens generated. So, previously, like the way you would generate JSON is you would actually write out in the prompt and say, please generate the JSON that adheres to the schema. And it's like, well, is it going to put it here or in the middle? And are there going to be backticks? Like, and now that support for that functionality is like a first-class citizen, right? And as they do more of this, it will gel much better with our systems, our kind of traditional deterministic systems. Yeah. So in this on this slide, yeah, on the slide, and I hope it's big enough you could see. And certainly in the demo, I showed that we're describing its behavior, right? So it's telling it, we're telling it like what its purpose is, and that it is an AI agent that runs an e-commerce store, connects to all these services, etc. There's another thing here where we have a way to connect like external data sources as one of the tools for prompt for basically RAG, right? So you can give it access to, let's say, an external data source and say the rules of this game, right? Which you know, whatever, like maybe it's a rule book that's kind of thick, so we don't want to put the full thing in there, but we want to let it know that it's able to look up the rules, right? And then we can write out in the steps and say always look up the rules when you encounter a specific scenario, right? So it will call into that service, right? And we do some sort of full text search or again vector search to look up the rules based on that query, and it will inject those rules into the prompt, and then that's what's kind of called in context learning, which is when the AI like uses this new information, learns this new information within the context. Yeah. Does that answer your question?
If we have an existing e-commerce system and we take this beautiful system and try to put it back into it, are you finding that you're having to how much change has to happen to that existing system to make this work, particularly if you don't have kind of a data set to double check and back test before you start working?
Yeah. Well, I mean, you should definitely be developing your evaluation data set, but just like I kind of ironically phrased it in this slide, you take the original Jira tickets that say as a user, I would like to be able to complete a new order, and these are the steps required. So you would take that, kind of reshape it, right, and try to extract some of this business logic and hand it off to an AI agent. Yeah, but the there's kind of an art to it, which is like knowing the limitations, like understanding the ripe use cases, slicing and dicing the problem correctly. So, and then yeah, do you answer? Yep.
So I was curious in this context how you think about hallucination. So, for example, you asked it about the total sales for a user that it knows, and I'm not surprised.
For a user about what?
For the user that it knows. So I'm not surprised it gave the correct answer for that. But if you asked it for a user that it didn't know, I wouldn't be shocked if it made up an answer. Based on the experience I've had working with LLM. So how do you think about hallucinations, as a problem to be addressed in this context?
Yeah. Well, this is where the structured output is able to shape the generated answer, right? Because so in this example where you say that I ask how much money what's the LTV of this customer, right? And the customer doesn't exist, so it tries to like hallucinate an answer because it was trained on some sort of adjacent data, right? Well, if we expect a structured answer, right, and that's the way that we interface with these systems, then it's going to generate something like customer email, Harry Potter at gmail.com, right? And we're going to connect our order management or customer management system. We're going to try to look up that customer, and it's not going to be found in the system. So I understand it's probably not to the full satisfaction the answer that I gave you. I also think that with time we will be able to steer these systems in a much better way in terms of operating within a certain context, right? So you will be able to narrow down its knowledge to specific areas, right? So these foundational models, they know about healthcare and history and medicine and mechanical engineering and I think we're going to be able to narrow down what you call latent space that it kind of operates in. So it will be a lot less likely to give you some completely out of place, outrageous answer. Yeah. So but does the error happen in the actual shipping label service? Is that what you mean? Yeah. So your service should be a good service. Well, I'll explain. Just like an API, right? When you interface with an API and it just returns a 500 with no body, you're like, what? So you could have the shipping service. And in some instances, for example, where it tries to look up the customer and the customer record doesn't exist, we just return a string that says customer not found, right? So it then uses that information to create the customer record, right? Because in the instructions we add create a customer record if new customer, right? So as long as you're returning an error message, and I mean you can connect to some sort of monitoring tools and that your developers are monitoring. But if you want to communicate that error to the AI agent, you should return that. You should say the shipping label failed. The shipping label creation failed because you didn't provide a shipping method, right? And at that point it should autocorrect and kind of resend that order, or I'm sorry, reissue that corrected API call. Yeah. Thank you.